All right, so let's talk about the Unit 3B FRQs, of which there are two. The first one, you're given a function, and you're asked to find the derivative. Show that the derivative is negative y over x plus y. So let's do that. 2xy plus y squared equals 8. For this part, I'm going to use the product rule. 2x times the derivative of y with respect to x, plus y times the derivative of 2x with respect to x, plus y squared, which would be 2y, but the y doesn't agree with the x, right? So you have to chain in dy dx, and the derivative of 8 is 0. So now I want to get dy dx by itself, so I'm going to factor it out of the terms that it has, and move this one to the other side. Divide both sides by 2x plus 2y. And then I could pull a 2 out of all those and cancel. And there's part A. Part B says write an equation for a line tangent to the curve at the point 1, 2. So we know we have a point 1, 2. We need a slope. Well, that's what we just found, dy dx. So we want the slope at the point 1, 2. So we plug in 2 for all the y's, 1 for all the x's. That's negative 2/3. And so the equation of my line is that. Part C, evaluate the second derivative at the point 1, 2. Well, we found the first derivative, so now we need to find the second derivative. So I have to take the derivative of my derivative, which is this, and I'm going to use the quotient rule. So we have low, d high, minus high, d low, over low low. And then everywhere I see a y, I'm going to replace it with 2. Everywhere I see an x, I'm going to replace it with 1. And everywhere I see dy dx, because it's at the point 1, 2, I'm going to replace it with negative 2/3. So let's see, my x is 1, my y is 2, times negative 2/3, minus negative 2, times 1 plus negative 2/3, all over 1 plus 2 squared. So let's see, 3 times 2/3 is 2. Negative 2, that's 1 minus 2/3, so that's negative 2 times 1/3, which is negative 2/3, but we're subtracting it. And that's all over 9. And then when I combine all those together, I'm going to multiply the top and bottom by 3 to make it a little bit easier on myself. So 8/27. And then part D. The points are on the curve. Find the value of inverse prime of 1. So remember, we have a formula for that. My inverse derivative is 1 over my derivative of my inverse. So I want to plug in 1. But remember, an inverse function takes in what would normally be the y value and spits out the x value that gave it to you. So in this case, we want this one, not this one, because that's like that one that's on the original function, not the inverse. So y inverse of 1 is going to be 7/2. And then y prime, again, is dy dx. It's the same thing. So I would plug in 7/2 into y prime. Now when we do this, here's y prime, right? So now that we're dealing with y prime, we've already dealt with the inverse part. This 7/2 is an x value. So 7/2 would be my x, and my y value would be this 1. So let's see, negative 1 over 7/2 plus 1. So that'd be negative 1 divided by 9/2. So it's negative 2/9. All right, the other FQ looks like this. Again, we're given a table. We've had a problem like that before. And you're asked a series of derivatives here. So part A says let the function be g and let it be defined. Thusly, ln of x over f of x cubed, find g prime of 2. So we're going to find g prime of x first. Quotient rule, low, d high, minus high, d low, chain rule, over low, low. And then I'm going to plug in 2. So I want f of 8, which is 6, which is 1 over 2, minus the ln of 2 times f prime of 8, which is 1/3, times 3 times 2 squared, which would be 12, all over f of 8, which again is 6, cubed. Sorry, squared. So that would be 3 minus 4 ln 2 over 36. And you could totally leave it like that. Part B. Give it a different function, ask to find the derivative and plug in -1. So this time the function is f of -3x. So chain rule, outside function would be f prime, inside function, leave it alone. Multiply by the derivative of what's inside. Again, another function inside, so multiply that by the derivative of what's inside. And now I don't have anything left inside. Plug in -1, get f prime of f of 3 times f prime of 3 times -3. F of 3 is 2, so this is f prime of 2. F prime of 3 is -2/5. And then f prime of 2 is 3/2. So I think that gives you 18 over 10, which is 9 over 5. And then part C. Let the function be a different k. And again, we're just going to start by taking the derivative. Oops, that's supposed to be a times, not an equal to arctan, which, by the way, you know is the same as inverse tangent of x over 3. So we're going to start with the product rule first, times the derivative of the second. Derivative of inverse tangent would be 1 over 1 plus that argument squared times the derivative of that argument, plus inverse tangent of x over 3 times f prime. And we're finding k of -3, so, sorry, k prime of -3. So we're going to plug in -3 for all the x's. So that would be -1 squared. Inverse tangent of -3 divided by 3. And f prime of -3. So f of -3 is 3. Sorry, f of -3 is 2. I'm sorry, -3. F of -3 is -9 times 1/2 times 1/3. Inverse tangent of -1, if you think about where tangent is -1, it's at the 45-degree angles. So that's going to give you -pi over 4. And then f prime of -3 is -7/2. So I'm pretty sure then we get -3/2 from this first part, and then plus 7 pi over 8. And you can leave it like